you and the courage of all these ladies and gentlemen to do this, having been on the other side. I will make one remark on background, and it's just a bit of human pride. I've been amused over the last 2 days that all these spacecraft mentioned that went to comets, went to Saturn, went to Jupiter, went to the Sun, and so on. Every single one of those was actually made by Lockheed Martin Corporation. So there's my ad. Thank you. But it is fun to see all that data put together, and it usually is never put together in one place. We're going to talk about the emerging science of life and some questions. I asked each of the panelists to put together some questions that they might like. Most of them did. The others I've talked with. Naturally, of course, I get to pick the questions, and I get to pick the ones in order, and I don't necessarily have to pick the exact questions that they ask, but that's the point of a panel. So I'm going to start off with what I think is a pattern from what I heard not only today, but the last 2.5, almost 3 days here. And I'm going to start with Jerry, and I'm going to ask Dr. Pollack, what can we take as foundational facts beyond any possible question?
Oh, Jim, you asked the difficult ones. I started my career accepting everything in the textbook as being true, automatically true, because after all, how is it possible to question the great people of science? And I found myself in various fields. The one that I presented here is just the latest of a bunch of different fields. The one I spent the most time in was muscle contraction. And I learned as I progressed that what seemed to be ground truth wasn't ground truth, because there were so many violations, so many disagreements between the accepted view and the evidence. And I thought it was unique to the fields in which I was immersed. And as people came to me, various friends who also have a somewhat skeptical point of view, I learned more and more about different fields, and I found that the situation was exactly the same in their fields as in my field. So I've come to appreciate that now in perhaps a few dozen fields I know about, there's a prevailing point of view, and there's an alternative point of view, and just as we see here, the alternative point of view doesn't really get much hearing except in those people who already know that the alternative has some merit. So I reached the point in my career where I don't accept anything. I'm not sure how much of the foundation that we come to accept as true is really true. And people have a tendency, my fellow scientists, to invoke, this principle or that principle. Well, how can you think that? Because the second law of thermodynamics says it's impossible, And so, well, how do we know that the second law of thermodynamics is okay? And you can't be an expert in everything, but you need to step back and take a look and really weigh the evidence. So I've reached the point where I'm not sure anything that can be taken as truth for sure.
Thank you. I would like to figure out how do we find real truth.
Yeah, okay, go on.
Yeah, right. We'll be here all day. So I'm going to go to Maewan and ask, is it useful to think of the universe as an organism?
Definitely.
And if so, why do you think so?
Definitely, because the short answer is because I'm thoroughly Whiteheadian, Bergsonian, and so on. And the second thing is, I think Rupert said it already, if you assume that everything is conscious, you don't actually have to put it back in. And the third one is very important, because unless you are an organism, understanding an organism, you cannot really understand nature. And that's what Whitehead said. And I have felt it very deeply in my heart that it is absolutely true.
Thank you. So, Rupert, do you see telepathy as a normal biological means of communication?
Yes, I think telepathy is a normal, not paranormal means of communication among members of animal groups. I've done a lot of work on telepathy in dogs and other animals. And I think that if it happens, it's happening all the time in the animal world. My starting point really is flocks of birds and schools of fish. You have collective behavior where large numbers of animals can be coordinated in their movements. Flocks of birds like starlings can change direction very, very rapidly, much too quickly for just looking at their neighbors and then responding. And these are basically field phenomena. And so I think there's a field of each social group, I call it a social field, binding together members of social groups. When members of the group separate, like wolf packs, when the young are left behind in the den and the old go out hunting, they remain connected at a distance. It's a kind of non-local connection. It's a bit like an invisible elastic band that continues to connect them. And there's evidence from field naturalist studies that wolves can remain in contact at a great distance, responding to what the others are doing by telepathy. I think the fact that domesticated animals like dogs, cats, parrots, horses form telepathic bonds with people is simply because we're part of the same social group. And when we look at humans, we find exactly the same principles. I've studied telepathy in the relations between mothers and babies, and that's a very normal, natural kind of telepathy that happens quite frequently. I'm currently mainly looking at telephone telepathy, which is the commonest kind in the modern world. 80% of people have had the experience of thinking of someone who then calls them. They say, "That's funny, I was just thinking about you." Or they know who it is when the phone rings. And it's not just knowing when someone's calling at a predictable time. I've done lots of experiments on that. I have an online test that anyone can do on their cell phone. It's on my website, sheldrake.org. And again, in the telephone telepathy and the human telepathy, it's nearly always between people who know each other well, parents and children, especially mothers and daughters, twins, close friends, close colleagues, and so on. So I think it's a normal means of communication among bonded members of animal groups. Some of the early parapsychology started from a kind of behaviorist platform and had people guessing meaningless symbols with complete strangers in separate rooms. That's not how it works in real life. It happens between bonded people. It's about needs. You need to call someone. It's about distress, emergency, and it's not primarily about thought transference. So I think it's perfectly normal, not paranormal, natural, not supernatural, just part of the way animal groups work.
Thank you. Having had personal experience of knowing when my own family or close family is, you don't need to call them, they're fine, even though they're supposed to have called in, right? Or when you should call them and they haven't called in, but they really should have called in because they are in trouble. It's a consistent thing in life. So, Dean, I'm going to give you the easy question you put out. Virtually all the world's religions and mystical traditions take for granted that certain superpowers exist. Mainstream science and scholarship today considers such claims to be superstitious at best. What is your opinion?
Well, the way I get into this topic is by asking whether Buddha was just a nice guy. Or for Buddha, you could substitute Jesus or Moses or Muhammad or other people with first names starting in M.
They're not hearing you.
Oh.
Louder.
Shall mentally project. I'm hearing an echo or a bell, though. I don't know why that's happening.
Because you're not speaking loudly enough.
Oh, in that case, I shall speak here. All right. Oop, now this is falling. It's falling. It's not good. All right, let's do that. So if you look at groups now, there are a couple of groups looking at advanced meditation research, and they work with the Dalai Lama has been instrumental in bringing together neuroscientists and physicists. The upshot of their discussions is almost always reaching a conclusion that Buddha was a nice guy, because there's no room to go beyond that possibility. The Dalai Lama himself has said many times, has tried to bring up the idea of the oracle that's used by the Tibetans, and ideas of the siddhis, or the special yogic powers that are produced by long-term meditation. And the scientists who are discussing this with the Dalai Lama are being kind and humoring him, and basically saying that there's no evidence for such things. So they drop the matter immediately. When I read that, and I'm sure when Rupert reads that sort of thing, of course our hackles are raised, because we know that that's simply not true. There's an enormous amount of evidence, not only for relatively simple or elementary psychic abilities, but for some of the more advanced siddhis as well. So at some point, maybe the Dalai Lama will win this argument, and there'll be a connection between what we actually do know within science about some of the supernormal capacities. So I use the word supernormal rather than supernatural. That sometimes the two are thought to be synonymous, but they're really not. Supernatural is a word that refers to a divine intervention. And science, almost by definition, cannot study the divine, because we don't know where to go look for that very well. But we can look very easily for supernormal effects. So at this point, I would say that at high-functioning telepathy and high-functioning precognition and the other phenomena that we know of, to have really high functioning of the sort that is described in the ancient yogic literature is very rare. So that's supernormal, because it's normal, but it's much better than we commonly see. When we do studies in the laboratory, we can confirm in principle that some of the legends that have come down over thousands of years of the special abilities that were claimed of Buddha and Jesus and Moses and the others, those things do exist. So it raises the debate. You would think that, for example, that within the religious scholarship world, among scholars who study religion, that this would be something that would be discussed, but it isn't. So it's not just science, it's within science and scholarship. This is almost uniformly ignored, because we live in a world where such things should not be able to exist. The fact is that they do.
Thank you. So Craig, does it feel good that I'm going in a row and then the nervous level goes up? How do you see your work on the concept of context as you studied in nature relate to things you've heard the last couple of days? And especially the issues and the concepts related to Jerry's work, or Maewan's, or Rupert's, or Dean's.
He was not here earlier.
I wasn't here the first day.
I know, but you were here the last two.
Well, that's a wide enough question I can say almost anything. So
The intent.
I mean, actually, something what I'd like to address in terms of context, and it's come up a number of times in the last 2 days, and frame it more as a question, and what can one do, is why is it that our educational systems have remained so resistant to change, resistant to change, to what makes sense? The way the university system has stayed so much the same over the past 100, 200 years, so little change. Of course, it's gotten more technological, et cetera, but fundamentally, very little change. Very little awareness of the needs of human beings to be creative people. So you have educational system where people come in and start teaching and have never studied the human being as a developing creature. I'm talking about university professors, right? I have 3 children who have just been going through the university, so I've gotten lots of this through conversations of the disastrous consequences, you can say, for many young people of professors who have no sense of the people they're working with. Where does that come from? And I think it's a certain inertia of the mindset that I was trying to describe this morning, of you have a sense of this is what one needs to know, and then you bring it out as knowledge. It was talked about this morning in the sense of rote memorization, and biology happens to be one of the worst subjects for that. And people don't think, or never, or at any point in their education are they encouraged to look at something for its own sake and say, what does it need in order to develop itself better? What does it need for its own conditions? But you're learning, if you were like me, through the public school system, what I learned is how to get through my tests in the best way. That's what learning was about. It was a strategy. It was never for the thing itself. So it seems to me, for context, if we look at context and it's the awareness of context and the practice of context in society and how it could lead to a culture that would be open to change, then we need to start in kindergarten and earlier with education that's based on experience and exploration, rather than on this is what someone needs to know for that. I mean, I hope you're aware of things like people are teaching PowerPoint in 2nd grade to their children. Well, why are they doing it? Because the children need to know it for 5th grade. Well, why do the 5th graders need to know it? Well, they need to know it for 8th grade. Why do the 8th graders need to know it? They need to know it for high school. We have this very short-term thinking of this for that, this for that, this for that, but not what is it that imbues the human being with characteristics to explore, to create, to think outside the box. And it seems to me that in terms of societal impact, we need to start looking much more seriously at a really heavy-duty revolution in education.
Thank you. I think my wife, who spent years in teaching, would like to help you put that. Yeah, she's clapping in the back there.
We'll talk later.
So, Wal, how do you see the concepts being developed within the EU community the last some years relating to those concepts that have been developed by your other panelists?
That's quite a big subject.
You got time?
This all grew out of the original desire to be able to explain the strange... yeah, that'd be better. Thanks. This grew out of all of these imagery and that David Talbot showed me, but earlier than that, Velikovsky's uncovering of the unstable solar system. I had the privilege of visiting him in his home in 1979, only a few months before he died. And my question to him was, what don't we understand about gravity? Because it was obvious that his challenge was to the gravity theory of the solar system and therefore also the universe. He gave me his tiny book, Cosmos Without Gravitation, and that gave the hint of how this electric force might operate. In other words, it was looked upon by Velikovsky as a dipolar electric force. That progressed a couple of years later, having that seed planted in my mind when I met Ralph Sansbury, and he had a model of electron structure. Now, electrons are not supposed to have structure, and with that simple model of orbiting smaller charged particles, he was able to describe both gravity and magnetism in very simple terms, and that appealed to me. Once you understand that gravity may be an electrical force, the question then is, how do you meet the requirement that was uncovered by several astronomers, including Tom van Flandern, that the electric force must operate far in excess of the speed of light for the solar system to be coherent? Tom van Flandern found, just from simple calculations based on close orbiting binary stars, that the speed of light would have to exceed 20 billion times, the speed of gravity would have to exceed 20 billion times the speed of light for that system to remain stable over the period that these stars were observed. that was a clue. Also, Ralph Sainsbury had given an initial clue because he calculated the speed of these tiny orbiting particles in the electron. If you tried to confine them to the size, the classical size of an electron, and those particles could be somehow liberated, those particles could travel from here to the other side of the Andromeda galaxy in 1 second. So this gives you an impression of the speed of the electric force. There was another aspect to it, of course. Once we had the polar configuration and the capture of Proto-Saturn, the brown dwarf, by the Sun, there are all sorts of other considerations. It means, for instance, that gravity can be modified by changing the charge on a body. There is no such thing as a universal gravitational constant. It's neither universal nor constant. You might ask, what's this got to do with organisms and so on? The point is that if all atoms are made up of a lower order of orbiting charges, and they can form these tiny dipoles, they can also communicate, if you like to put it that way, or via this invisible elastic band, as Rupert said, of electric force between molecules. There is an instantaneous communication system. And when you think about it, living systems rely on an instantaneous communication system between all of the complex chemical operations that are going on in your body every microsecond. So I think that the universe is an organism, as Maewan Ho was asked, because all matter in the universe is obviously connected by this electric force. What's more, quantum theory can now be understood by this, through this connection as resonant, coherent communication between similar or like atoms, like particles, like molecules. And I think this also goes some way to understanding the specificity of telepathy and so on. The more alike you are, or the more contact you've had, which can lead to modifications, of course, within you, the more easy I think it is to communicate. So the electric universe, unlike the Big Bang, actually does have something possibly useful to say about life, the universe, and everything.
Thank you. That's good. So, I'm the moderator, so I get to moderate, so I get to ask the questions, but I also get to change form a little bit since I'm up here. I'm going to ask the panel members, a few more questions. There is a mic over there that can be used. You've all taken some notes. I think of each other's talking, so I'm going to give you a chance to perhaps ask each other questions or comments you want to make once you've heard each other. But I'm also going to give an opportunity for members in the audience to come up and ask a question or two of the panel, and I'll let you decide I'm going to take that one or not, the case may be. I'm going to go back to Jerry for a minute. So how do we define life? There's two easy ones now.
Yeah, two easy ones. I don't think anybody has come up with a satisfactory definition of life. For example, if you take a seed, is a seed living or is a seed non-living? Seeds can be in existence for 100 or thousands of years and then spring back to life as soon as you add water. But is the seed itself alive or not alive? It's not defined. Personally, I think the question is not well posed, if you'll pardon me, Jim. No, I think I came up with a question.
I was trying to be helpful. I can rephrase it for you.
No, I think the reason I say this is that in our experience in biology and in chemistry and physics, I guess, we found that almost every life function can be simulated in the laboratory. And for example, if you take, those of you who are biologists will know, if you stick an electrode into a cell, a living cell, if you measure the potential difference between the inside and the outside, you get 100 millivolts or so. And many people used to think that this was a very important distinguishing factor of life, because the membrane, after all, the membrane of the cell is central for producing this potential difference. And then we found, or other people found too, that if you stick the same electrode into a gel, not a cell, no membrane, you get the same result. So this is kind of puzzling, you know. And then another definition, I mentioned the membrane. Some people think, well, the membrane, the cell membrane is the essence of life. If you've got no membrane, you don't have life. You have a membrane, that's really important. But I found among many people, many reports of people taking cells and basically slicing the cell in half. And the surprise is that the cell doesn't always die when you do that. And so you've basically decapitated the cell. You know, and the cell is able to do just fine. In fact, it can go on to divide and produce more cells as though nothing has happened. You can take a fibroblast cell sitting, producing connective tissue, sitting on a glass surface. And these cells are nice. You can watch them crawl along. And sometimes the rear end of the cell gets stuck onto the glass, but the front end breaks free, keeps moving with the same velocity. It doesn't know that it's been decapitated. It just goes on and on. So there's no membrane, but the function is fine. So, you know, if you go back to some of the fundamental aspects, they don't exactly fit. Even movement, Albert St. Georgi, you know, as I mentioned, the father of modern biochemistry, he said life is motion, life is movement. But you know, we found in the laboratory that we can get lots of movement without life. So my own personal thought is that there's no sharp boundary between living and non-living. It's a continuous progression from one to the other. And if you'd like to define life, you can just take some arbitrary cut and create a boundary. But I think the question is, again, I say, maybe not well put.
Oh, why did you put it?
Thank you.
Well, we were posing these questions for other people.
So I'm going to go over to Rupert. I'm going to skip Maewan a minute. See, I get to surprise you.
Oh, good.
And the question I'm going to ask Dr. Sheldrake is, you had a question on the missing heritability problem and how morphic field resonance shed light on it. I'd like to enlarge it or change it a bit. How do you see what you call morphic resonance related to what Jerry and others are wrestling with, what is life, and how does it relate to that?
Well, morphic resonance is a memory principle in nature. And the reason I think we need it is in an evolutionary system like biology, or indeed the whole cosmos. An evolutionary system depends on what's happened in the past. And memory is a key thing for that. The existing cosmology we have based on eternal mathematical laws is a universe that's completely amnesic. Everything's constantly determined by a kind of eternal principles which can't themselves evolve. So I think memory is an essential feature of any truly evolving system, and it's an essential feature of evolving life. And it's an essential feature of any continuation of any organism. Organisms are not solid things that just persist in time. They're continually recreated. They have to be, even an electron, it's a wave. A wave has to keep making itself to be a wave. So I think that this resonance is both one of the keys to the continuation of anything by resonance with itself. Self-resonance is the basis of continuation. And in living organisms, what they inherit is a resonance from the past, from their own past, which maintains their own form. I think our own memories depend on resonance, not on storage in the brain. We have our own memories, not other people's, because we're more similar to ourselves in the past than to anyone else. Identical twins are similar to their twins, and they, I think, resonate quite a lot, causing them to be very similar. Then when people find they're similar growing up separately, they say, oh, it proves it's all in the genes. I don't think it proves anything of the kind. And because this gives an inflated view of inheritance through genes, the identical twin studies, when you come to what genes really do through the Genome Project, the Genome-Wide Association Project, has shown that in many features like height in human beings, genes only account for about 5% of it. And this leads to the missing heritability problem. Most of inheritance is unaccounted for by the genes or even by epigenetics. So I think that morphic resonance is the key feature for understanding inheritance and evolution, collective memory on which members of each species draw and to which they contribute, is different in degree but not in kind from individual memory. Both depend on the resonance across time. So I think that resonance is the key, this resonant process, and it also means that because memory doesn't have to be stored in phosphorylated proteins or modified synapses, anything that's self-organizing can have a memory. A galaxy can have a memory, and a sun can have a memory, even though it's far too hot to have hard drive-type memory storage. By self-resonance, there'll be a memory built in to everything. And coming back to the thing about what is alive, I would think self-organization is one of the key things, because I think the sun's alive, but it doesn't reproduce like a biological organism. I think the universe is alive, and as far as we know, it doesn't bud off other universes. It might do, but I think the galaxy is alive. So I think life is to do with self-organization, movement towards an organism's or a system's own ends or goals, and a self-recreation through memory, through resonance with itself in the past, and a collective memory of similar things elsewhere.